off the coast of Vancouver Island. The crew explores the ocean with a remote-controlled submarine that can dive down to 5,000 meters. These short research missions happen only a couple of times a year when the weather is good. Such limited access is a big challenge for scientists like Kim Juniper, who are trying to understand the ocean's complex problems.
We're getting decreases in biodiversity, we're getting crashes in fisheries, the oceans are warming as a result of climate change. All these things have been accumulating over the past century, and it's getting to a really critical tipping point here that if we don't better understand what's going on in the oceans and how our different resource exploitation activities are affecting them, we're going to be in big trouble very soon.
To better understand what's going on in the oceans, American and Canadian scientists came up with a bold concept to set up a network of remote-controlled underwater observatories on the West Coast, all linked to the internet. Neptune Canada will be the largest cable underwater observatory in the world, a publicly funded project of over $100 million. Neptune will survey 6 areas off of Vancouver Island. Each of these sites will have a central node powering a wide range of scientific instruments, cameras, and hydrophones. The MV Thompson's voyage is also Neptune's first major step. The crew must survey the ocean floor to choose the exact location of the observatories. We are at Barkley Canyon, an area that contains large reserves of natural resources. The submarine slowly descends into a rich ecosystem.
Just let the bridge know that we're on the bottom.
Oh, bridge lab, ROVs on the bottom.
Star of some sort. We got a large fish.
Right.
Every time a new oceanographic expedition goes out to sea and makes the effort of collecting organisms, particularly from the bottom, where most species live, we inevitably bring back species that are new to science. We're still trying to get a handle on the biodiversity of the oceans. Right now we have something in the order of 200,000 to 300,000 species that have been counted in the oceans. And there's some people that estimate there are 6 million or more species in the deep sea. So we're just seeing the tip of the iceberg.
We continue our voyage, and 300 kilometers out at sea, we reach the mysterious area of Endeavour Ridge. Here, the submarine dives very deep, below 2,000 meters. It's like landing on another planet, constantly disturbed by volcanic activity. No light ever reaches these depths. Crushing pressure and extreme temperature near these black smokers make it one of the most unwelcoming places on Earth.
That's like 300 degrees right now, right?
Yeah.
But surprisingly, life thrives down here.
I've been working there for over 20 years now, trying to understand how these things change over time and how these ecosystems can both tap into the energy of the volcano and at the same time avoid getting smoked, burned by hot water, or even covered by lava.
Colonies of tube worms grow here. Their red plumes contain bacteria that help them feed off of oxygen and sulfur present in the water.
They're found nowhere else on Earth. This is an ecosystem that is essentially not dependent on solar energy to live. It's just living on heat from the mantle of the Earth. And in many ways, it's an ecosystem that we could find on other planets.
They look like upside down islands.
Beautiful.
Neptune won't only study biodiversity. The crew will set up cameras, tsunami and earthquake detectors at the bottom of this ridge.
Neptune will allow us to watch these things directly and better understand, for example, how does the fauna respond to this? How do they adapt to an environment that's essentially living on a volcano?
1 month later, in August 2007, the Ile de Saint arrives at Neptune's shore station in Port Alberni on Vancouver Island. it begins laying over 800 kilometers of fiber optic cable, which will supply power to the scientific instruments and transmit data.
It's an enormously exciting day. There's been a lot of planning. There's been hundreds of scientists involved in developing the whole idea of this whole network, and to actually see some hardware going in the water is really exciting. What's key about this location and why we're going off the west coast of Vancouver Island is that we're adjacent to one of the smallest tectonic plates in the world. It means we can go right across a tectonic plate. That means that we're in a whole series of environments.
From the shallow waters of the continental plateau to the depths of the abyssal plain, the cable installation requires 2 months of hard work. After a few cable breaks necessitating repairs, the backbone of Neptune now lays on the ocean floor.
We can do the final test for the DB1.
July 2009. 2 years have gone by. In a warehouse north of Victoria, the team finishes assembling dozens of scientific instruments. They test them in a container full of seawater for several days to make sure there are no electric leaks.
There's a level of effort that goes into just placement of instruments on the seafloor that you don't want to be trying to do it twice if you can avoid it. So we've gone through a very extensive testing program that's perhaps more analogous to sending something out into space.
And just like missions to Mars, Neptune has its own rover.
One of our more charming instruments, I think it's fair to say, is the crawler, who's got nicknamed Wally. He's developed to work in methane hydrate fields close to Barkley Canyon.
Voilà. Hop, on est dans l'eau.
Methane hydrates, which we see in yellow, are formed by methane encapsulated in ice. These are a large source of untapped energy. But methane is also a greenhouse gas that, if released in large quantities, could trigger rapid global warming. Wally can move from one hydrate to another to collect scientific data.
We took Wally the crawler down for a field test to the floor in Barkley Canyon. He did really well running downhill, magnificently. But as soon as the ground leveled off, he started to dig in, essentially like a car in the mud or the deep snow, and he got stuck immediately.
Wally, sure enough, did need some new shoes, and so he has now got treads that can cope with very muddy substrates.
So you can go ahead right away.
So what we've been doing today is actually taking Wally for a run in a muddy patch to see how it does operate.
September 2009. There's only a few weeks of fair weather left to complete the final installation of Neptune. The crew works around the clock to lower down all the scientific equipment and to connect it to the network.
When you plug an instrument in underwater and you power it up and it doesn't operate properly, you have to make a decision. Do I then take time to recover this instrument and maybe try and fix it on the deck of the ship? Or do we just live with it not working?
Despite a few minor setbacks, the team successfully connects most of Neptune's equipment, including this hydrophone that can capture the sounds of whales.
Okay, I'll just tilt up a little bit now.
End of October 2009. Scientists are busy doing preliminary testing from Neptune's control center at the University of Victoria.
And I believe we have a problem.
So we have to reset Wally's breaker?
Yes.
Okay.
There are a few bugs to iron out, but by and large, it's mission accomplished. Even Wally can be remotely controlled hundreds of kilometers away.
Okay.
Okay.
Cheers.
Do I have control now?
Now you do.
Right. Come on, Wally. We have hardware on the seafloor and it works. And we can really go online now and see these instruments. It's quite a moment. It is a paradigm shift as far as the way that we do ocean science because we're sharing data. So no one's keeping data in file drawers in their offices anymore. This is all open to the entire world.
A new window has opened on Neptune's kingdom, allowing everyone around the world to take a peek at what happens in Canadian waters. Scientists and even citizens can now try to unlock the ocean's deepest secrets. Frédéric Zalac, CBC News, Victoria.
Definitely an amazing project. For more underwater images and videos, visit the Neptune Canada website at www.neptunecanada.ca. And don't forget to check out our website too at newsandreview.cbclearning.ca. And that's News and Review. I'm Carla Robinson. Thanks for watching.